रेजोनेंस की, इलेक्ट्रिक रेजोनेंस. सो टुडेस टॉपिक इज योर इलेक्ट्रिक रेजोनेंस. सो इलेक्ट्रिक रेजोनेंस क्या चीज होती है? जैसे हम लोग ने अभी एसी सर्किट हम लोग समझ रहे हैं, तो एसी सर्किट में दिस इज स्टार्टिंग फ्रॉम दिस इलेक्ट्रोमैग्नेटिक इंडक्शन. सो इलेक्ट्रोमैग्नेटिक इंडक्शन में हम लोग जो यूनिफॉर्म मैग्नेटिक फील्ड्स होती है, यूनिफॉर्म मैग्नेटिक फील्ड्स में कोई कंडक्टर लेते हैं या कंडक्टिंग कॉइल, है ना. सो व्हेन वी आर टेकिंग कंडक्टर और कंडक्टिंग कॉइल, तो इसमें ऐसा ये कोई कंडक्टर और कंडक्टिंग कॉइल और जैसे PQ मान ले. सो व्हेन इट स्टार्ट्स रोटेटिंग, so this magnetic line of forces are cut by this rotation of this conductor. So due to this rotation of this conductor, so this magnetic field is converted into change in the magnetic field. And according to the Faraday's laws of electromagnetic induction, change in the magnetic field always produces EMF, and that is called as induced EMF. The EMF which is produced, so it is called as induced EMF, and the EMF which is produced, the current which is produced, it is called as induced current. And the EMF and current, so that is E is equals to that E naught sine omega t. So where omega t is omega is your angular frequency, E naught is a peak value of EMF, and E is a magnitude of induced EMF, and similarly I is equals to, this is I naught sine omega t. So where I naught is a peak value of current. Clear? तो इलेक्ट्रिक रेजोनेंस में होता क्या है कि जैसे ही हम लोग कोई भी एक यहाँ पे, चाहे हम लोग RLC लगा दो, R लगा दो या L लगा दो या C लगा दो, R फॉर रेजिस्टेंस, L फॉर इंडक्टेंस एंड C फॉर कैपेसिटेंस. अगर मैं RLC लगा दूं और RLC के अक्रॉस में अगर कोई अल्टरनेटिंग सोर्स में कनेक्ट कर दूं, सो अल्टरनेटिंग सोर्स कनेक्ट करने के बाद में, सो दिस प्लस माइनस, दिस इज E is equals to, this is E naught sin omega t. So when you are connecting the alternating source to the any electrical appliances या कोई भी equipment, so when there is I is a current flowing through it, so यहाँ से जब हम लोग यहाँ ये AC source जिससे हम लोग कनेक्ट करते हैं, so this RLC receiving some frequency, because this is a AC source. In AC source there is a continuously change in the frequency, continuous frequency change होती रहती है, and in DC source there is a frequency is constant. So for AC source there is continuously change in frequency, that means frequency is fluctuating in alternating current, and in direct current the frequency is constant. So when there is a frequency is constant, so it is called as direct current, but we are applying here alternating current, so it means that the frequency is gradually changing, या frequency is changing. So when this frequency which is received by this component, या the frequency which is received by resistance, inductance and capacitance, so the value of impedance, so that is Z is your impedance, the value of impedance become maximum or minimum. ये impedance या तो maximum हो सकता है या तो वो minimum हो सकता है. So impedance become maximum or minimum, and when the impedance become maximum or minimum, when this AC source, the frequency of AC source is gradually changes. That means this is complete, this is AC source. When the frequency of AC circuit is gradually changes, then the value of impedance, yeah, otherwise then the impedance become maximum or minimum, so it is called as electric resonance. So it's very simple definition for electric resonance. What is electric resonance? When the frequency of AC circuit is gradually changes, जब frequency AC circuit का gradually change हो जाएगा, so when the frequency of AC circuit is gradually changes, then the value of impedance, या otherwise the impedance become maximum or minimum, is called as electric resonance. So that is called as electric resonance. So now see, depending upon the value of maximum and minimum of impedance, so there are two types of electric resonance. दो types होते हैं electric resonance के. So depending upon the value of impedance, that is if it is maximum and if it is minimum. If it is maximum, so again there is one type of electric resonance. If it is minimum, so there is one type of electric resonance. Clear? So when the source of again I am repeating the electric resonance. What is electric resonance? When the AC, the frequency of AC circuit is gradually changes. जब frequency अगर AC circuit का gradually change हो रहा है, so the value of impedance, so the impedance become maximum or minimum, is called as electric resonance. So dependency on, so the dependency of impedance, whether it is maximum, whether it is minimum, so the electric resonance are of two type. If it is a maximum, so electric resonance are of one type, and if it is minimum, so electric resonance are of second types. Clear? So there are two types of electric resonance. दो types है electric resonance के, कौन से है वो समझ लेते हैं अभी. So now first is electric resonance का पहला type. This is called as series resonance. Series resonance. So this is the first type of electric resonance, series resonance. And then second is parallel resonance. Parallel resonance. There are two types of इलेक्ट्रिक रेजोनेंस, सीरीज रेजोनेंस एंड पैरेलल रेजोनेंस. तो दो प्रकार के रेजोनेंस होते हैं, इलेक्ट्रिक रेजोनेंस, सीरीज रेजोनेंस और पैरेलल रेजोनेंस. इन सीरीज रेजोनेंस वी हैव टू कनेक्ट इन अ सीरीज कॉम्बिनेशन. So it means that you have to connect inductor along with the capacitor, that is should be ideal capacitor, that is pure inductor, and pure resistor that should be connected in series. And again this series combination is connected across the alternating source of EMF, that is E is equals to E naught sine omega t. So where I is the current flowing through the circuit and this is L, C and R. So this is a series combination because in series resonance we have to use a series combination between L, C and R. So L stands for inductance, C stands for capacitance and R stands for resistance. So L is your purely inductor, C is your ideal capacitor and R is a pure resistor. And this series connection is connected across the alternating source of EMF, that is E is equals to E naught sine. So this is a series combination. Now parallel combination. In parallel combination, so there is two connection between this EMF, between this inductor and capacitor. Why we are not taking resistance here in parallel combination? Because the phase difference between EMF and current in resistance is zero. So when the phase difference between phase difference in resistance in EMF and current, so it is zero. That's why we are not taking here resistance in parallel combination. So now this is again connected across the alternating source of EMF. So that is again plus and minus. This is E is equals to E naught sine omega. So again this is I is your current flowing through this circuit. I is current flowing through the circuit. So this is your L and this is your C, inductance and capacitance. So inductance and capacitance. So this is IL is the current flowing through the inductor. IC is the current flowing through the capacitor. There is a junction, so that's why I is equals to IL plus IC. I आपका IL plus IC हो जाएगा because there is a parallel combination. But in parallel combination there is division of current. In parallel combination voltage remains same, so that's why voltage across this EL should be equals to voltage across this EC. So EL and EC, voltage across EL and voltage across EC should be same because here is parallel combination. So that's why we can say that E is equals to EL is equals to EC. So this is for the parallel combination. So it's only general introduction between series resonance and parallel resonance. Series resonance and parallel resonance are the two types of electric resonance. So electric resonance, the frequency of AC circuit is gradually changes, then the impedance become maximum or minimum. So it is called as electric resonance. Depending upon the value of impedance is maximum and minimum. So electric resonance is divided into two types, that is series resonance and parallel resonance. So this is a schematic diagram for the series resonance and this is a schematic diagram for parallel resonance. Now we are understanding individually, that is the series resonance and parallel resonance.